should walk over there. I mean, that's exactly how it is. All right, I did grade Lab 1, and I want to mention just a couple of things. First of all, read my notes. A couple people I was not able to compile their code, so I don't know, maybe there was a problem. A couple people asked like what you needed to do, and you know, what files you need to send. Really, you only need to send the .java file because I will recompile it, and I probably will recompile it anyhow, just to make sure everything is okay. A couple people, and a couple people do this every semester, is they posted a question to the Dropbox. It's better not to post a question to the Dropbox. It's better to email me a question. And the reason for that is I grade typically once per week. I grade a class's stuff, which means if you ask a question, I'm not going to see it until I go grade it. Whereas my email I check daily for the most part. And therefore, even if you upload something to the Dropbox, if you think it's complete, let's say, and you upload it, but then send an email and say, hey, what I uploaded to the Dropbox, I have A, B, and C question about it. All right? If you didn't get full credit, you're welcome to resubmit it. Kudos to people that name their variables meaningful things. Like, for example, in a Mad Lib, noun, verb, adjective, color, something like that. That definitely increases the readability. Another thing that I want to mention is that some of you used only one random variable. And the problem is not really a problem per se, but the problem then is you don't get as much variety in the Mad Libs. In other words, if you generate a random number 1, you're going to use element 1 from each of the 3 or 4 or however many lists that you have. If you were to generate as many random numbers as you have lists, then you will guarantee that you have the maximum flexibility, and those lists can work independently. So in other words, I think the reason for that is I think people looked at my example and said, oh, I'm going to do the same thing. I'm going to generate a random number. All right? But I only had one list. If I had 3 lists, you know, a name, a verb, and an animal, then I would generate a random number for the name, a random number for the verb, a random number for the animal. And that way I would use the random number when I was outputting that. If you would ever need the random variable to agree, for example, if you wanted the same name in the second sentence as you used in the first sentence, then you just generate one random variable for those 2 particular items. But you would use a different random for each list. The other thing, question that I kind of asked in class, and I never really got around to answering it, but it's relevant as far as this assignment goes, is we want to make this as flexible as possible. And right now, if I were to add a name to this list, this code wouldn't really be perfect, right? Because it's still generating a random number between 0 and 3. All right? And therefore, I would never get the name Pete. The least that you have to change with the program, the better it's going to be, because I won't then have that oversight. All right? How could I make this so that I would not have to change this number to 5? Yes?
The way I did it was I put the name of the string array length.
Yeah, names.length, I believe is the right answer. And what that does then is that that doesn't have a hard-coded value. That has, oh. And that way, all you have to do is change the array, and you never have to change that again. So if you add, delete, whatever to that list, then you're all set. All right? That's a good thing. I mean, that should sort of be our guiding principle, that we don't want to have to duplicate effort. So if we see a section of code, and if we say something is going to change with this, we're going to add an item to the list, or we're going to delete an item to the list. What else do we have to do? If there's something else we have to do, then maybe we ought to think about, gee, is there a way that we could write this so that if I add something to the list, that's all I need to do? And in this case, using the length of the array would be the answer to that. And again, using descriptive variable names is a good practice, and so on and so forth. I think that's all that I had as far as this goes. For this to work best, use the array length to indicate how many elements are in it, as opposed to hard-code a number. And you really should have a random number for each one. That would guarantee that the list would work independently. All right. Last time, and we sort of rushed through this, so we're going to take our time to sort of rewind and review it in more detail. But I created a class for pizza. And again, a class the word that one student used was it's a template. In other words, if we're going to make a pizza, these are the things that we can do with it. These are the characteristics that pizza has. These are the behaviors that we can perform on the pizza or ask the pizza. All right? It should be everything that's important to us as far as a problem goes. All right? So in this example, it's important for us to know the size of the pizza. It's important for us to know whether it has pepperoni or not. It's important for us to know what kind of crust it has. So therefore, all of that is encapsulated or contained within the pizza class. We don't have some of that living in one place and some of that living somewhere else. All right? So whatever is relevant to the problem that you're trying to work ought to be encapsulated in that. Because what we're doing is we're creating a template for any pizza that we choose to create. All right? When we create a pizza, this is what our system needs to know about a pizza for our system to do its job. Now, as you can imagine, maybe in our hypothetical pizza restaurant, there's a number of different pieces of functionality that we need to perform. We need to, for example, bill the customer to charge them the correct value for their order. We need to give them a time of how long the order is going to take, right? Because the one kind of pizza takes longer to bake than the other. And therefore, we could have a lot of different applications or sections of applications looking at this pizza class to get some information from it. The idea here, though, is we're making a component. That any place that we need to use a pizza, whether it be the calculation for, like, how much time it's going to take to bake for this order, or the pricing to know how much to charge. Everything about that is going to be in this template for pizzas. And then when we make a pizza, we use this template and supply the specific values for your pizza and for your pizza and for your pizza. Okay? So that's what we do when we define a class. So here we have our class for pizza. And let's pay attention to a few things. All right, I'm going to actually make a small cosmetic change. I'm going to indent all this stuff. It's not absolutely required, but I think it's a good practice. Again, why is something a good practice? Because it leads to maintainability. It's easier to read the code if it's nicely indented and so on. First of all, some naming conventions. Class names are capitalized. So public class pizza, that should be capitalized. Things that are not class names, for example, This is an attribute name. It's not a class name. This is a variable name. This is a function name. Use what's called camel case, where the first part of it is lowercase, the first word is lowercase, and then each successive word is capitalized. So, has pepperoni. This isn't a class, so therefore we don't capitalize the H, but we do capitalize each subsequent word. So, has pepperoni. Set size, set crust, and so on. All right? So class names are capitalized. That's the first convention. These braces indicate the beginning and ending of something. This is where it's nice to have an editor like Notepad++, because if you notice, I can easily, if I put my mouse and click on that brace, I see that that brace belongs to that brace. It's color-coded. You don't get that with regular Notepad. That's very useful because, again, if you have a lot of code, especially if you get into if statements and things along that line, and loops and functions and all sorts of things like that, the code can get pretty complicated. So it's nice to know what brace belongs to what. All right? The other thing that can help you is properly indenting. So notice that everything within the class, within that class brace, is indented. When I declare a function, I have the brace and the starting brace. Everything within that function is indented. Over here where I have an if statement, everything inside the function is indented. The true and false sections of the if statement are also indented. One thing that we stressed last time is that variables are to be made private. Either private or protected. And by variables I mean attributes, characteristics. These variables here. These are the characteristics that are relevant to our pizza. This is what we've decided for our system is important to know about a pizza. What size it is, what kind of crust it has, and does it have pepperoni or not. Now again, if we expanded this to include other toppings and different kinds of sauces and so on, we may have other attributes. But we decided this is what we need to know for our particular application. All right? They are made private. Private means that these attributes cannot be accessed outside of this class. And we said that's a good thing. The principle for this is called data hiding. That we don't let the outside world access the data. All right? Well, if no one can access this data, how can we make a pizza and tell the pizza that it's small, medium, or large? And how can we say what kind of crust it has and so on if we can't access these attributes? Go ahead. Oh, yeah, through the methods. In other words, we provide a method to access those things. And it's a question of control. If I write a method that allows people to put in that this is a large pizza, this is a small pizza, this is a medium pizza, and so on, and it has pepperoni or whatever, I can put things like validation rules in there. All right? In our case, and we're not doing that yet, we're just discussing why we're taking this particular approach that we're going to build upon later. So for example, our pizzas can only be small, medium, or large. It's the only three values. So we could actually create it that you would only have, your method would only accept those as valid values. If another program tried to create a pizza and say it was XL, for example, or XS for extra small, then you would get an error, which is exactly what you would want to have happen. So this allows us to do and have control over the way those attributes are handled. Think of the attributes as kind of like being like the innards of a circuitry board. All right? You don't want anyone that is plugging a mouse into the computer to have to open up and wire the mouse to the motherboard or something like that. That would be a disaster. All right? You want to sort of protect that motherboard. You want to only allow people to access the mouse port on the motherboard through a very specific way, by plugging it into the right place in the back. Same thing with speakers, same thing with monitors, and so on and so forth. In other words, you provide ways that people can access the stuff that's on the inside of the computer. All right? How does we provide a way through the video cable to access the video card inside the computer. And again, we do that for protecting everyone. So you don't have to worry about dealing with the innards of the computer and attaching stuff directly to the video card. You just use the port in the back to connect it. Same idea here. We have control over how those variables can be accessed, so we can make sure that those variables are not compromised, that the integrity of those are not compromised. So, private attributes. And what that means, though, is that in order for us to use those variables, those attributes, to access them and to set them, we need methods. And for each method, we are going to have a get and set method. We'll just look at one of these set methods because basically they're all the same. The only difference being, in this case, one of them has a different type of data. Public means the outside world can access it. That's a good thing, right? People, other classes that are creating pizzas, for example, if we had a GUI that would allow you to create a pizza and click on the size and click on the kind of crust and so on, it's going to need to create a pizza object. Well, it's going to need to tell that pizza object what size it is, what kind of crust it has, and so on. So we need something that public, that is the outside world, can access. And that's not going to be the attribute itself, it's going to be the method. And this method is public, so any other class can access it. Void is the return value. In other words, there is no return value. That's what void means. This function runs and it doesn't give anything back to whoever called it. Set size is the name of the method, and this accepts a single argument, which is a string. We simply take that argument, whatever got passed in, and plug it into the size attribute. So that's how we set the size of a pizza. We don't access the attribute directly. We call the set method. And if we look at the test class here, that's exactly what we do. We call the set size method and we pass it an L. The other set methods work the same thing with the exception of has pepperoni, expects a Boolean. So we have to give it a true or a false. Get size, get crust, and get has pepperoni are the getter methods, and they provide sort of the opposite functionality. In other words, it's going to be important for us, for our pizza, to be able to describe itself so that if we print out a receipt or instructions to the driver of what we're delivering or whatever, we say that here's a pepperoni pizza, small pepperoni, thin crust, thick crust, plain pizza. So we need to be able to get these out of the object that we create. We need to be able to ask the pizza, hey, what size are you? What kind of crust do you have? Do you have pepperoni on it or not? And that's what the get methods involve. So the get methods, again, public indicates that the outside world could ask the pizza what size you are, or what kind of crust, or if you have pepperoni. The return value, the return data type rather, is going to match the data type up here. In other words, if we ask the pizza what size are you, we are going to get back a string. And that's what that says. We're getting back a string because that's the kind of data this is. So whatever we have here as the data type for size, that is going to match the argument in the set and the return value in the get. It makes sense. If we say that the size is represented as a string, all right, then, well, when we give a value to that attribute, we better give it a string. And when we ask for that value back from the class, we're going to be getting a string, because that's what that is stored as. Now, we wouldn't have to do it this way, right? We could have, for example, maybe the sizes of pizza instead of small, medium, and large were 6-inch, 10-inch, and 14-inch, something like that. In which case, maybe an integer would be the size. But again, if we made the size an integer, then we would make the attribute an integer. The argument that we would pass to it would be an integer. And the return type when we returned it would be an integer. All right? It would all match. And the get methods do the exact opposite. Instead of allowing the outside world to set an attribute, it returns to the outside world the value of a particular attribute. All right? Keep in mind that there may be all sorts of things going on here, programs that use this class. We're creating a class that could be used by multiple other classes. So there might be a class that allows that's associated with the GUI that allows the placing of an order. There might be a class that prints the receipt. There might be a class that prints out a daily summary that says how many pizzas we sold, how many were large, how many were small, medium, how many were thin crust, thick crust, and so on. This one class is our pizza component, and it will be used in any application or part of the application that needs to do something with a pizza. Finally, we have another kind of method that actually does a calculation for us. It does a calculation based on the size of the pizza, and I guess that's it. No, not the size, the kind of crust. That if it's a thin crust, it takes 10 minutes to bake. If it's a thick crust, it takes 16 minutes to bake. And we return that to whoever asks for it. Now, the bake time is a double. I could have defined it as an integer, but by defining it as a double, I think that gives us a little bit more flexibility. Maybe our chef comes in and says, you know, I've been working with these pizzas, and those thin crusts are better if instead of 10 minutes, we make them 9.5 minutes, right? So that's why I declared it a double. Simply, there'd be nothing to change if they decided they wanted fractional minutes, all right? This method, again, is going to return a double. There's no arguments to it. And it does its thing. It initializes a bake time to 0. It tests to see what kind of crust it has. And if it's thin, it returns 10 minutes. If it's thick, it returns 16 minutes. So we set that variable and then return at the end. This is a stylistic thing. This is how I like to code. I like to have only one return. All right? I've seen other people code differently where they would say return 10, return 16. And I probably won't yell at you if you do that, but sort of the way I was taught is that every function only has one exit point. It makes it a little cleaner and a little easier to troubleshoot in my mind. So therefore, I have only that one exit point at the very end where it returns the final answer. And in the meantime, we store it in a variable till we are ready to return it. One thing you should notice, this is how we compare strings with the equals method. Equals is a built-in method for strings. All right? Method for strings, does that mean that strings are objects? Absolutely. How do we know that strings are objects? Or rather, what was our first hint that strings are objects? When I declared my string variables, I declared it with a capital S. So string is a class. All right? And therefore, members of that class are objects. So string is a class, size is a string object. And this method to compare to see if this string equals that string is necessary because of the way that object reference variables are stored differently than what are called primitive variables. We'll talk about that in a couple weeks' time. Just know that if you want to compare values of string variables, you would say this, and you would not say if crust equals then. This has a potential of giving erroneous results. And again, I'm not going to get into it right now, but you wouldn't do that. You would use the equals method, like this. Yes, it's mainly with strings. And without going into details, strings are classes and string variables are string objects. Yet, most developers more or less think of them like they're primitives. So Java put in a couple of things that allow you to cheat with strings and act like they're primitives. So for example, well, I don't have a good example. But you can, in your instructions, you can treat strings in a manner that sort of looks like they're primitives. If it's not a class variable, it's a primitive. So Boolean is a primitive, int is a primitive, double is a primitive. We'll really get into this in a couple of weeks. All right, but essentially, yeah, string is the exception because when they created Java, they wanted to allow people to have it both ways. Have strings really be objects, but be able to sort of act like they're primitives. All right. So in this case, we've defined the template for a pizza. We've defined what is important for our application about pizzas. These three things we deemed. What do pizzas need to be able to do? Well, we need to provide a method to set those attributes and to retrieve those attributes. And that's what the getter and setter methods do. We also need the ability in our problem domain to calculate the bake time. Again, and that is based on the value of those attributes. So this is the template. This is not an individual pizza, but this is sort of the template for all pizzas that we are ever going to create. All right, this is the form of a pizza. And again, normally, in a real application, this kind of code would be hooked to like a GUI. So that someone came in, you would select what kind of pizza they wanted. All right, what the toppings were, what the crust was, what the size was, and so on. All right. Since we're not at the point to create GUIs now, we are connecting to what's called a unit test class. And a unit test, as is sort of implied, unit usually means like one thing. So we are simply testing our pizza class through this unit test. There's two kinds of testing that are done in software development. There's unit test and there is system testing. Unit testing is where each individual component is tested by itself to make sure that it worked. System testing is where the whole thing altogether, the whole application altogether is tested to make sure that it works. Think if you were testing a car, right? You could test the battery to make sure that the battery provided a charge. You could test the spark plugs to make sure that the spark plugs sparked. You could test the fan belts to make sure the fan belts were correct and all the other belts, and the gas tank to make sure the gas tank worked, and a fuel pump to make sure that worked, and so on. Unit testing would be testing each of those pieces individually. System testing would actually be being to try to drive the car, right? Because you're testing all those things together. Because all those things could be working, but if they're not like hooked together correctly, it's not going to work. Like maybe if you have the terminals on the battery reversed or something like that, all right? Or there's a problem with the cable for the battery or whatever, all right? So each of the pieces could be working, but maybe the way that they're connected isn't working, and that's system testing. So here is what our unit test class looks like, and is incomplete. All right? Because we're only testing one case in this particular situation. We are testing that the bake time for a large pizza for a thin crust pizza is correct. If we truly wanted to test this, we'd have two test cases in here. A test case for a large pizza or a thin crust pizza, and a test case for a thick crust pizza. So, this is the class that we're going to have that contains our main method. Public class unit test, capitalized. Notice these file names are simply the name of the class with .java after it. This is the class that we're running, so public static void main. That's going to be standard. String args, those are the optional arguments that we could pass from the command line. And here's where the real fun starts. Let's analyze this line. All right? Looks like an innocent enough line, but we could take a long time talking about this. Pizza P equals new pizza. We actually could split that up into two commands. So this line is sort of the equivalent of these two lines. Okay? So let's look at these two lines first, and then this will just be sort of pushing those two things together. What does pizza P say? Okay. Pizza is capitalized, so we know it's a class. All right. What this is saying is we have a class named pizza. All right. Which we better have a class named pizza for this to work. Right. Otherwise we compile it, it's going to give us an error. Or if it's spelled wrong. Or if it's spelled with a lowercase p instead of a capital case P or anything like that. But we have a class named pizza. And P is going to be a pizza type variable. We're going to store information relating to a pizza in a variable named P. All right? So P is going to point to a pizza, is what this says. It's almost like we had this line somewhere. Double bake time. This is saying we have a variable that's a double, and bake time is going to be a variable that is a double. This means that we can do pizza-like things to our variable P. Anything that you can do to a pizza, you can do to the variable P. This is simply, so this line here is simply saying I have a variable P that's going to contain a pizza. It doesn't actually create a pizza, though. At this point, if I tried to do anything to that variable p, I would get an error. All right? I would get an error because I've said that the variable p is going to contain a pizza, but I haven't created a pizza yet. I've told it it's going to contain a pizza, but I haven't gone and made that pizza yet. This line goes ahead and actually creates the pizza object. All right? That's a lowercase p equals new pizza. This is going to match the variable that we called it. Now, if you put this together on one line, we've declared that we have a variable that's going to store pizzas, and we've gone and we've made the pizza. So our variable p now points to a pizza object. What is a pizza object? Again, it's a specific member of that class. The class defines a template. The class defines what's true of all pizzas. All pizzas have a size, a crust type, whether they have pepperoni or not. And we can calculate the bake time for all pizzas. P is the specific pizza that I am making right now in my kitchen. All right? That's going to get delivered to you. All right? And so on. I'm going to go into, in reality, what happens here. And bear with me, because we'll go over this in more detail. There's two areas of memory. The stack and the queue. Oh, no, not the stack and the queue. I'm thinking of something else. I'm thinking of data structures. A stack and a heap. Variables are created on the stack. The actual objects are created on the heap. And what a variable contains for an object is the pointer to the memory location where that object lives. So let's go through these instructions from the stack and heap perspective. If I were to say pizza p, p equals new pizza. After this instruction executed, I would have a variable on the stack contained that's going to contain a pointer to p. But there's no object on the heap yet. So it would be a null pointer. We're going to put a pizza pointer in there, but we haven't yet. So if I tried to do anything with p, I would get an error. And that error would be null object reference. Remember those words, because that's a very, very, very common error to get. And a null object reference is when you've declared a variable, but somehow that variable is not pointing to an actual real object out on the heap. And there's a bunch of ways that that could happen. All right? We won't talk about them all now. But this, p, creates the variable on the stack and leaves the pointer empty because we haven't said what we want to point it to. P equals new pizza The new pizza part goes and allocates the memory needed for the pizza object. Now, our pizza object is pretty small. It just contains a few things. But some of these objects could get really big. So memory allocation is a big deal. So by saying new pizza, that actually creates the pizza object on the heap. And if I say P equals new pizza, then P is going to get set to the memory location on the heap where that object lives. Sometimes you'll see, like if you read about Java, it will talk about pointers. This is what a pointer is. In other words, P doesn't itself contain the object. P contains a pointer to where the object lives. Object variables are better termed, more accurately termed, object reference variables because they refer to where that particular thing is stored. So, if we combine these two, then all that happens in one step. Boom, you have the variable and you have the object in the heap, and the object on the heap points to, or the variable points to the object on the heap. All right. So now, that we have a pizza object, we can do pizza things to it. All right? First one we can do is we can set the size of it. We can call P. So this particular pizza is going to be a large pizza. This particular pizza is going to be a thin crust pizza. This particular pizza does not have pepperoni. We can then ask the computer, or the Java virtual machine, to tell us what the bake time is for this particular pizza. And it will run out and calculate it and return the results to us. So we're calling the methods. At this point on, we're calling the methods for this specific pizza. We've created a pizza. We're now calling the methods for this specific pizza. All right. Now, I mentioned before that this really isn't a complete test, right? Because we know that our test, that the bake time for a pizza depends on a couple of different things, right? It depends on a thin crust versus thick crust. So I've tested one of the possibilities. What I should do is I should test the other possibility too. And I could do that a couple different ways. I'm going to do it this way. Remember, this is our test code. I don't really care if this code is the best code in the world, because this is our unit test code. We're going to discard this once we get the entire system up and running. So I'm going to make another pizza. And I'm going to set the properties for that. And I can ask for that pizza. What's the baking time? So now I have two different pizza objects. Sort of a trick question, if I were to, not a trick question, but if I were to ever ask you how many objects get created, two objects get created. How do I know that? Because I see the word new two times. New means an object gets created. So I have two pizzas, one of which I set with one set of parameters, one of them I set with another set of parameters. So I'm going to go save this. I'm going to compile my unit test. Run it. And it tells me that thin crust is 10 minutes, bake time for thick crust is 16 minutes. All right. When you test your application, you need to test it thoroughly. All right, thoroughly. So running it one time through with one set of values doesn't test your application unless it's a very, very, very simple application. All right? So you were asked to create a student class for LC and to calculate tuition. And here's the chart for calculating tuition. Let me sort of review how this chart works. First of all, there's 3 columns. There is from 1 to 12 credit hours, you simply take the rate, and there's a different rate for each of the 3 kinds of students, and you multiply by the credit hours. For 13 through 18, it's simply the rate multiplied by 13. In other words, you get up to 18 for the same price that you pay for 13. And then from 19 on, you start incrementing it up by an hour at a time. So in other words, the tuition for an in-county student for 19 credit hours is the same thing as the student for 13 credit hours plus 1 extra credit hour, plus 2 extra credit hours, plus 3, plus 4. All right? How many test cases should you have at the very, very, very least? All right, 3. And what would those test cases be? Okay, you would need below 13, 13 through 18, and then above 18. Yes? Correct. You would also need to test in-state, out-of-state, and out of county. So really, at the least, I would say you need 9 test cases. All right. Probably need more. We're not going to talk about that today, but probably need more than 9 test cases. But you at least want, so in other words, you would want 1 for each section of this chart. This row up here, this row up here, this row, the middle section, and the end section for all 3 columns. Now, we haven't written very complicated functions yet. All right. But let's take a quick stab at writing. Well, instead of doing that, let's talk for a minute about what your function is going to look like to calculate the tuition. At its most fundamental level, your tuition is your hours times your rate, right? So, that's at the most basic way of looking at it. If we didn't make that special deal for 13 through 18 credit hours, if we didn't have different kinds of students, that's what the tuition charge would be. Just the rate times the number of credit hours. Now, we do have those other conditions. We do have the 3 types of students, and we do have a special little catch in our calculation for different hours being charged different things. So here's how I would approach it. I would have an if state. Really, this depends on the type of student. The hours billed depends on the hours taken. So I would have a statement like this towards the end of my function that simply says tuition equals hours times rate. You know, the nice thing is you could leave it at that and test it out to make sure your code worked. And then you wouldn't turn it in like that, but then you could continue to work on it to refine it. So don't think you have to do all this in one shot. You could just worry about the first group, the 1 through 12 for in-county students and just get that calculation working. You would then have a series of if statements for if, depending on the kind of student, you'd set the rate differently. So you could have 3 if statements that tested what kind of student they were and assign a different rate to them. You could then have a series of if statements that said, okay, if hours are less than 13, then we are going to bill them for however many hours they're taking. If hours are between 13 and 18, then we're going to bill them for 13 credit hours. And then there's also a formula for if it's above 18. So think in terms of tuition equals hours times rate, return tuition, and then think of having 2 blocks of if statements, one of which sets the correct rate and one of which sets the correct number of hours that the user is going to be billed for. And then you write a test class similar to the one I did, and you will test it thoroughly. So you should have at least 9 different test cases. All right? Any questions about this? It is unfortunate next week that we do not have class on Monday. Well, let's put it this way. I don't know if it's unfortunate or not. It's nice to have a day off, right? But if you're having difficulty with this, I can be a little lenient on the due date of this. We'll talk more about this Wednesday of next week. But try at least to write part of this code. Try and just write the code to do a basic tuition function, and then you can come back later and finish it up. All right? Any questions about that? Yes?
How many students should we put in our?
Well, how many test cases did we say we needed at the very least? 9. So there should be at least 9 students. Because again, there's 3 possibilities for the hours, there's 3 possibilities for the rate. So you need to test each of those possibilities at the very least. I won't even get into it, but if you got into being real clever with how you write your test code, you could actually generate that chart and create 3 students, all right, and have a loop to do credit hours from 1 to 22 and just test that way. That would be another acceptable way to do that. If you want to take the brute force method in hard code, you should do that for at least 9 students. Any other questions? Absolutely. Java has for loops, and they work just like they do in C#. C# is sort of a derivative of Java. So that's one nice thing. If you know C#, if there's something that you like in C#, chances are those instructions are going to be very similar in Java. Are there other questions? All right, we'll see you up in lab.